there. Welcome to the week 5, part 3 of our learning guide for college algebra. Can't believe we've made it this far. We have had set out to have 8 weeks of learning guides, and we're more than halfway. So I'm super excited. I hope that you are really getting the benefit from these examples and they're helping you in your class. Now, the biggest thank you can say to me is to make sure you hit that like and subscribe button and keep watching the videos so that you get more and more. Let me know if there's a particular concept you'd like to see another video of. I'd be happy to do that. So let's dive right in. This is part 3 of the week 5 learning guide. We're going to talk about in behavior and zeros. Now, I've given you a picture here because I see a lot of confusion between the words roots, zeros, and x-intercepts. Friends, they all mean the same thing. Roots are zeros, and zeros are x-intercepts, and x-intercepts are roots. They all mean the same thing. So when we look at a polynomial and we're asked to find the roots, we approach it the same way as if we're asked to find the zeros, or the same way as if we approach it to find the x-intercept. So we'll keep that in mind as we're looking. Let's start with problem number 1. We're asked to consider this function and determine whether it is a polynomial function. Now, poly means many, and nomial means terms. So when you're looking at a polynomial, there's a few things to consider. One, you can only add or subtract terms together. So this is a term and this is a term, and we are adding and subtracting between them. Perfect. No multiplication or division of terms is allowed. Okay. So yes, this is a polynomial here. And then we're asked to state its degree and write it in standard form. Now, standard form has the highest exponent first, and then the exponents decrease from there. So we would rewrite this one as negative x cubed plus 5x. That would be in standard form because the highest exponent is first, and then the powers decrease. The degree would be that highest exponent. So that highest exponent would be 3. We call that the degree. Now, let's look then at number 2. We're going to look at some graphs of polynomials. And for this one, I want to use our Desmos graphing calculator. I will link it below. That way you can access it too. It's totally online and free, and I love that part about it. But let's graph these two. We're asked to graph g of x equals x to the 5th. And then we're asked to graph h of x equals x minus 3 to the 5th. Okay, so we started with the blue one, and I'm going to zoom in just a little bit. There we go. We started with the blue one. We ended with the green one. So I'm going to do the blue one in red because I don't have my blue pen ready. And friends, we're just looking for a sketch, a general idea of what that looks like. And then the green one, it looks like it's been scooted over. I noticed Desmos is highlighting that point for me that it might be important. So, and it is, that's that turning point, we call those. So what was the transformation? What happened to the blue graph here on Desmos to give us the green graph? You're right. We shifted right 3. It's pretty easy to see that from the graph, but I want you to see that you also could have seen that from the equation there. Very helpful. By the way, I didn't mention this at the beginning of the video, but you can download this learning guide in the description. I will link it there for you. That way you can access it if you don't have a copy and you want to follow along. Please feel free to do that. All right, friends, let's look at number 3 then. Number 3 asks us to consider this function, and let's consider its in behavior. Now, I'm going to rely on my good friend Desmos. Let me type in this function. M of x is x minus 3, x plus 2 squared. Okay, and I'm going to zoom out a little bit. Oh, okay. I get the idea. Get it what it does, right? I'm going to go back in a little bit. I'm just clicking. There's a plus and minus over here on the right side of Desmos. You can always do that. So it's asking me for end behavior. That means as it goes off the graph to the right and the left, what do the y values do? So here's how we write this. We say as x gets bigger, and I'm going to use an infinity symbol for that. So it means as we're going off the graph to the right, I'll do it backwards for you guys, off the graph to the right, what do the y values do? The y values get bigger. You notice that they went up, right? Then let's do the other end behavior. Let's do the right side. So as x gets smaller and smaller, this time I'm using negative infinity. Then y values are also going up. So that's all we're doing. We're just talking about as the graph goes off to the right or to the left, what do the y values do? That's how we describe the end behavior. B says, find the intercepts. Well, friends, remember, Desmos is super smart, so it highlighted those intercepts for you. They are -2, 0, and move your cursor over here, 3, 0. It said determine the zeros and their multiplicity. Okay, so remember, x-intercepts are the same thing as zeros. So the zeros here, we're just going to say x equals -2 is a 0 and x equals 3 is a 0. We just say it in a little different way. Okay, the multiplicity of -2 comes from looking at the equation. So you'll notice there's an exponent of a 2 on there. That means, oh, friends, you know what? I typed my graph has an exponent of 3 and I need an exponent of 2. Okay. Well, that changes a little bit. We'll come back and fix that. Um, so my multiplicity at -2 is actually this exponent here, 2. My multiplicity at x equals 3, look, has an exponent understood of 1. So its multiplicity is 1. Now, the only thing that changed here is notice that when I go off the graph to the right here, the y values go down. So I'm going to change that one as x goes to negative infinity, y goes to also to negative infinity. But other than that, that's all that we're looking for. Remember, the multiplicity comes from looking at the equation and getting the exponent there. All right, one more, and we're still going to rely on Desmos for number 4. We're asked to graph this function. So let me type it in. P of x. P of x equals x to the 4th minus 2.4 x to the 2nd plus 0.36. Okay, really nice there. Now look at, you're asked to describe the end behavior. So on this one, as x goes off the graph to the right, so as x approaches infinity, we use the arrow with the infinity, the y value gets bigger. Same thing when we go off the graph to the left. So as x goes to negative infinity, the y value also gets bigger. And you can use that notation there for it. You're asked to sketch a graph. Okay, I could sketch just a general idea, looks something like this. Okay, find the intercepts. Remember, Desmos did a lot of the good work for you. These aren't pretty intercepts, and that's okay. Negative 1.4960 and negative 0.401. And then use the next one, 0.401. And that last one is 1.496 and 0. Okay. Now the last question asks us to identify the turning points. These are the max and mins. And again, Desmos has identified these for you. So we have minimums at negative 1.095, negative 108. I have another minimum over here at the positive of those. And then we have a max at 0 and then 0.36. Okay, so friends, please, please use your Desmos graphing calculator to help you with identifying these, but know what these words mean when we're looking for turning points. zeros, x-intercepts. What are we looking for to write about the end behavior? All of that very important here. So don't forget to leave me a comment if there's something you'd like me to be sure and do another video of or explain further. I would love the opportunity to do that. And as always, thanks for watching. Bye-bye.